Good afternoon, all. Am I audible? Hello. Am I audible?
Yes, ma'am.
Okay. So today we are going to start with revision of unit number 1. Before that, can you tell me which points we should revise? Because already we have revised this chapter. So I think this is second revision. So this is our syllabus. These are the points. So you can tell me which points you want to be revised. First chapter is easy. So I think all points are easy and you have understood, but still we are going to revise it. Is what do you think? Which point should be revised? Okay. If there is no response from your side, then I will revise all points shortly. So in this chapter, what we have seen in the introduction part, we have seen what is statements and notations. Then we have seen different type of connectives, that is negation, conjunction, disjunction, conditional, biconditional, and for each and every of these connectives, we have seen definition, truth table, and examples. Next one is well-formed formulas, then tautologies, equivalence of formulas, duality law, tautological implications, functionally complete set of connectives, and other connectives. So all these points we have already seen. Just we have to revise these points shortly. So first we have seen first point as statement notations. So here we have seen what is definition of statement. So what is this statement? Any sentence for which it is possible to assign either true or false value, that is called as statement. And so we firmly can decide whether that statement is having truth value as T or F. Then only that sentence is called as statement. Then we have seen many examples which are these statements and which are not. If you consider this sentence, close the door, then this is not a statement. Why? Because this is an order. We can't assign either true or false value. That's why this is not a statement. After that, we have seen what are the different types of statements. So again, we have broadly categorized statements into two types: primary, atomic, or primitive, and second one, compound or molecular. Okay, so these are the two categories: primitive, atomic, or primary, and second type, compound or molecular. So what is meaning of this primary or primitive sentence? A statement without any connective, that is called as primitive or primary or atomic statement, and a statement which is formed by using sentential connectives, that is called as compound or molecular statement. Again, we have seen examples based on it. So we can say the example for primitive statement is today is Sunday. So if you consider this one, there is no any sentential connective. So what is meaning of sentential connective? And or these are the sentential connectives. Again, but we can consider. But here in this statement, there is no such a word. That's why this is called as primitive, atomic or प्रायमरी स्टेटमेंट. एक जर सिंगल स्टेटमेंट असेल तर ते प्रिमिटिव्ह असणार आहे आणि जर तुम्ही दोन स्टेटमेंट कनेक्ट करून जर सिंगल स्टेटमेंट फॉर्म केलं तर त्याला काय म्हणणार आहे आपण कंपाऊंड स्टेटमेंट. फॉर एक्झाम्पल टुडे इज संडे अँड इट्स हॉलिडे. So here we have connected two different statements using sentential connective, and that connective is and. That's why this one is called as compound statement. Are you getting this? Hello? Are you getting this?
Yes, ma'am.
Okay. After that, we have seen different types of connectives. So there are 5 types of connectives. First one is negation. So what is this negation? How we can form negation for any particular statement? So there are 2 different ways to write the negation for any statement. First way, by introducing phrase, it is not the case that. And second one, we can place not word at proper place in the statement. So in both the ways, we can form negation of statement. So consider here, statement P is given. So London is a city. And then how we can form negation for this statement P? And that is written by negation of P. So this is the symbol for negation. So we can form the negation by using phrase, it is not the case that London is city. And second way, we can place not word at proper place. So second way is London is not a city. So in the both the ways, we can form negation of this given statement. Again, the truth table for negation. If P is the variable, then its negation is written by negation of P. If P is having truth value as T, then its negation will be having truth value as F. If value of P is F, then value of negation P is T. Okay, so just we have to give alternative, or we can say opposite value. If your statement is having value as T, then its negation will be having value as F. If your statement is having value as F, then your negation will be having value as T. So again, there are some alternative symbols are available for this negation. This is one of the symbols that we have said. Then negation can be written as this one, this symbol, or we can write a bar or word not. So these are the some alternative symbols for negation. After that, we have seen the second kind of connective, and that is conjunction. So what is meaning of this conjunction? Conjunction is AND operator. So if there are two different statements P and Q, then conjunction of these two will be written as P conjunction Q, and which is read as P and Q. Okay. So again, what is the value for this P and Q? If both P and Q are having their truth values as T, then only final value for P and Q is T. Otherwise, it is F. Means what? T, T, T. Otherwise, for all remaining combination, its value is F. Now check here. If there are two different statements P and Q. Okay. So how we can form conjunction of these two statements? P is given as it is raining today. and Q is given as there are 20 doubles in this row, and we have to form conjunction. Conjunction means what? And operator. So we have to write there and word. So it is raining today and there are 20 doubles in this row. So this is the conjunction for these given statements. So again, we can write its truth table as P, Q, and this is for P and Q. Okay. So again, here two variables are there, P and Q. That's why your truth table will contain 2 raised to 2, that is equals to 4 combinations of truth values, and those are given here. P, T, T, F, F, for Q, T, F, T, F. And again for this P and Q, what is the condition? If both P and Q are having truth value T, then only final value will be T. And for rest of combinations, it is F. So that is given here. Now, third connective, that is disjunction. Disjunction means what? Or operator. So the disjunction of any two statements P and Q is statement P or Q. So this is the symbol for disjunction, and this can be read as P or Q. This statement P or Q has truth value F only when both P and Q have their truth values F. Otherwise, it is true. So from this statement, we can form truth table for this disjunction. So its final value is F when both P and Q are their values F. Then only final value is F. Now look here. Here PQ and this is P or Q. So TT, T, TF, T, FT, T, FF, F. Means what? When both variables are having their truth values F, then only final value will be F. So this is related to disjunction. Now next operator is conditional operator. So here, if there are two different statements P and Q, then statement P conditional Q, which is read as if P then Q, is called as conditional statement. And so if there are two different variables P and Q, the conditional for these two variables can be written as P conditional Q. And how we can read it? If P then Q. Then this statement P conditional Q has a truth value F when Q has truth value F and P has truth value T. And for rest of combinations, its truth value is T only. In short, for this conditional operator, if value of P and Q like TF, then only final value is F. And for rest of combinations, it is T. Now check here. This is the truth table for conditional operator. Now check here where we have written TF. Value of P should be T and value of Q should be F. Now in the second row, that value comes. That's why final value here is F. And for rest of combinations, it is T only. Now, if you observe this formula, P conditional Q, P is called as antecedent. Why? Because this is the first variable from this formula, and Q is called as consequent. So these are the two terms assigned for these two variables. P is antecedent and Q is consequent. So again, P conditional Q, this is equivalent to negation P or Q. So this formula is very important and you have to remember it, because you know that every time we have used this formula. P conditional Q, this is equal to negation P or Q. And the last connective is a biconditional. So what is this biconditional? If P and Q are any two statements, then P biconditional Q is read as P if and only if Q, and that is written as P if and only if Q. This statement P biconditional Q has truth value T whenever both P and Q have identical truth values. So this is the condition. So what is meaning of identical truth values? The P and Q च्या जर values same असतील, PT, FF, then only its truth value is T. Otherwise, it is F. So that is reflected here in this truth table. P, Q, P biconditional Q. Now check here. T, 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 F, F, T, because both P and Q are having identical truth values. And for rest of combinations like TF, F, FT, F. So this is the truth table. So again, P biconditional Q, this is equals to P conditional Q and Q conditional P. So again, this is one of the important formula. P biconditional Q is equals to P conditional Q and Q conditional P. So these are the 5 different connectives. So do you have any doubt up till now?
No, ma'am.
Okay. बरं, रिव्हिजन मध्ये आपण एक्झाम्पल पण रिवाइज करायचे का फक्त थेअरी पार्ट बघायचा आहे? काय करायचंय? Yes, I want input from you. Hello. हॅलो. तुम्हाला सांगा, तुम्हाला कशाची जास्त गरज आहे रिवाइज करायची? थेरी रिवाइज करायची, एक्झाम्पल्स का दोन्ही रिवाइज करायचे?
Theory with one example, ma'am.
Theory with one example of each type. Okay. Okay. So here we have seen P biconditional Q, this is equivalent to P conditional Q and Q conditional P. So we can prove this. How? By using truth table. Now here we have seen what is the truth table for P biconditional Q. So now we will form truth table for P conditional Q and Q conditional P. And then we will check whether these two formulas are having same values. Then only we can say these two are equivalent. Now here we have to form truth table for this one. The variables are P, Q. Then we have to write P conditional Q, Q conditional P, and last column P conditional Q and Q conditional P. So here values of truth P is TT, FF, values of Q, TF, TF, then value for P conditional Q. So what is the value for this conditional? If TF, then only F, and for rest of combinations it is T. That's why its values are P, F, P, T. Now again, we have to find the value of Q conditional P. So for this Q conditional P, again same rule, but here first variable is Q. So first of all, we have to look into second column, that is column for Q. Now check whether there is any combination like TF. So here in this third row, value of Q is having T and value of P is F. So again PF, its value is F. That's why we have written here F. And for rest of combinations, it is T. Now next one is conjunction operation between these two columns. So again, what is conjunction? If T, T, then only T. And for rest of values, it is F. Now check here, in the first and last row, both the values are TT. That's why final values are TT. And for rest of two columns, it is FF. Now here in this last row, we got value, last column, we got values as T, F, F, T. Now check whether these values are same for P biconditional Q. So here is truth table for P biconditional Q. So again, it is having values as T, F, F, T. In short, both the values are same. That's why these two formulas are equivalent. P biconditional Q, this is equivalent to P conditional Q and Q conditional P. So likewise, we can prove it using truth table. Okay. Again, these kind of examples they may ask, like write the following statements into symbolic form. Okay. So here one statement is given. If either Jerry takes calculus or Ken takes sociology, then Laurie will take English. Okay. So we have to transform this sentence into symbolic form. So first of all, we have to identify how many statements are here. That is atomic statements without any connective. So first we can take J as Jerry takes calculus. This is first statement. Second statement, for that we have taken variable as K. So K as Kane takes sociology and L as Laurie takes English. So here three statements are present. Those are atomic statements. So now we can transform this sentence into symbolic form. How? If either Jerry takes calculus or, so first statement or second statement, and variable for first one is J or second statement is K. That's why these two first atomic statements are connected by OR symbol. That's why we have written here or disjunction. Then. So again here if then form is there. So if then means what? Conditional. So we have written here conditional. And last one is Laurie takes English. And for this one our variable is L. That's why its symbolic form is J or K implies, or we can say conditional L. This is a symbolic form. Have you understood this? Hello? समजते का काय केले? Okay.
Yes, ma'am.
Yes. Good. Okay. Now next part is a well formed formula. This is very important because in each and every question paper they have asked question based on this well formed formula. So what is this well formed formula? how to check whether given sentence or given statement is well-formed formula is not. So there are certain rules. By help of those rules, we can check whether it is well-formed formula or not. So first of all, we will revise the definition. A statement formula is an expression which is a string consisting of variable, parentheses, and connective symbols. And the recursive definition of statement formula is called as well-formed formula. Means what? Well-formed formula is nothing but a statement formula. So again, what is statement formula? A formula which is consist of variable, parentheses, and connective symbols. That is a statement formula. And recursive definition of statement formula is called as well-formed formula. So there is no any difference between statement formula and well-formed formula. So again, some rules are given by which we can identify whether given statement is well-formed formula or not. So these rules are: rule number 1, a statement variable standing alone is called as well-formed formula. Any statement we can consider. So that statement is always well-formed formula. Second one, if A is well-formed formula, then negation of A is well-formed formula. If A is our statement, then negation of A is a well-formed formula. Third one, if there are two different statements, A and B, and if these are well-formed formulas, then A and B, A or B, A conditional B, A biconditional B, all these are well-formed formulas. So what we can say, if you apply any connective like and, or, conditional, biconditional, then all these are called as well-formed formulas. And last one, a string of symbols containing the statement variables, connectives, parentheses is a well-formed formula if and only if it can be obtained by finitely many applications of rules 1, 2, 3. Means what? If you form any string and which is consist of which is obtained by applying rules 1, 2, 3, then that is a well-formed formula. So these are the 4 rules to check whether it is well-formed formula or not. So here some examples are given. Those are well-formed formula. Now check here. If you consider the first one, it is negation of P and Q. Check here. What is well-formed formula? It must be consist of parentheses, variables, and connective symbols. Now check here. It is containing parentheses, also variables are present, and connective symbols are also present. That's why this is a well-formed formula. Again, all these 5 are well-formed formulas because these are satisfying above 4 rules. But if you consider here this example as negation P and Q, this is not a well-formed formula. Why? Because it is not containing parentheses. We can't define whether this negation is applied to P and Q or only to variable P. This is not specified here. That's why this is not a well-formed formula. And reason we can give as missing of parentheses. So again, if you consider this second example, this is also not a well-formed formula because here first bracket it is fine. This is well-formed formula. But if you consider this second bracket, this AND operator is applied to Q only. But here there must be any another variable here at this place because AND operator can be applied on only 2 variables, minimum 2 variables, but here only 1 variable is there. So here this is not a well-formed formula, and reason we can give as missing of variables. So now likewise we can consider third one. Here this is also not a well-formed formula because one parenthesis is missing. Again, in the fourth example, same case is there. Again, here is missing of parenthesis. Opening bracket should be there, but that is not here. That's why this is not a well-formed formula. So this is the rules and definition related to well-formed formula. Do you have any doubt regarding this point? Hello? समझले का हा point? Well-formed formula? Hello? Any doubt up till now? Understood. Good. Now, next point is tautology. So, what is meaning of this tautology? We have already seen. If your last column is containing all the values true, then that is called as tautology. If your last column is containing all the values F, then that is called as contradiction. And for that purpose, they have given one example here. Variable P is taken, negation P, then P or negation P, P and negation P. So here we have to form truth table for all these formulas. So two formulas are here, these two. So P is TF, negation P is FP. Now we have to form P or negation P. So P or negation P, TF, T, FT, T. Why these values are T only? Because for this disjunction, if both are having truth value as F, then only final value is F. But here TF, FT. So at least एक जर T असेल तर तुमची final value T येणार आहे. That's why value for this column is TT. Now for T and negation P. So here for this AND operator or for this conjunction, if both the values are T, then only final value is T. Otherwise it is F. But check here TF, F, FT, F. Because no any combination is containing both the values T. That's why all the values are F here. So here we can say that this third column is tautology because it is containing all the values T, and this last column is called as contradiction because it is containing all the values as F. So again we can say that the negation of contradiction is tautology or negation of tautology is contradiction. These are exactly opposite. जर तुमच्या last column मध्ये सगळ्या values T असतील, then that is tautology. If all the values in last column are F, then that is called as contradiction. And if in any case, if your last column is containing some values as T and some values as F, then we can say that this is neither tautology nor contradiction. That part we will see later. Now, next point is a substitution instance. So, how we can define, how we can form substitution instance of any formula that is given here. A statement formula A is called as substitution instance of another formula B. If A can be obtained from B by substituting formulas for some variables of B with the condition that same formula is substituted for same variable each time it occurs. So this is the definition for substitution instance. So any formula A, this can be substitution instance of any another formula B. But if it is obtained by replacing some variables of B with the condition that same formula should be replaced for same variable each time it occurs. म्हणजे काय, जर तुम्ही सबस्टिट्यूशन एखाद्या व्हेरिएबल साठी दिली तर ते व्हेरिएबल त्या फॉर्म्युला मध्ये जितक्या वेळा आले तर तेवढ्या वेळा सेम फॉर्म्युला आपण यूज केला पाहिजे. देन ओनली A is called as substitution instance of B. Now check here. Here formula B is given and that is P conditional J and P. Okay. Now suppose here we want to substitute formula R by conditional S for this variable P. Okay. Then whatever formula we will get, that will be substitution instance of B. Now check here. What we decided, we have to replace this P by R by conditional S. Now check here. This formula B is containing P twice. That's why we have to replace this P twice by formula R by conditional S. So after substitution, we got formula as R by conditional S, conditional J, and again this formula R by conditional S. Then here A is called as substitution instance of B. का म्हटलं याला substitution instance B ची? Because here we decided to replace variable P of B using R by conditional S. आणि जितक्या वेळा P त्या फॉर्म्युला मध्ये आहे तितक्या वेळा ते आपण रिप्लेस केले कुठल्या फॉर्म्युल्याने? R by conditional S. So after replacing whatever formula we got, that is called as substitution instance of B. Have we understood this concept? समजलं का सबस्टिट्यूशन इन्स्टन्स? जर काय तुम्हाला डाऊट असेल, अजून पण काय समजलं नाही असं असेल तरी आताच सांगा, परत तर काय रिव्हिजनचा चान्सच नाहीये. दिस इज फायनल रिव्हिजन. What should I consider? You are understood. Okay. So here the definition for a substitution instance is, suppose the मराठी सांगते, जर तुमच्याकडे दोन फॉर्म्युलेज आहेत, ओके, फॉर्म्युला बी आहे, फॉर्म्युला ए आहे, तर ए ला आपण सबस्टिट्यूशन इन्स्टंट बी ची कधी म्हणणार आहे? जर तुम्ही बी मधले व्हेरिएबल्स रिप्लेस केले बाय युजिंग सर्टन फॉर्म्युला, then that A is called as substitution instance of B. Again there is one condition. If you have replaced one variable from that formula B, then you have to replace the same variable. If that variable occurred many times, then same variable should be replaced by same formula. This is the condition. Then only A is substitution instance of B. ह्या फॉर्म्युला मध्ये बघा, आपला फॉर्म्युला बी काय आहे? P conditional J and P. So here in this formula P is repeated twice, and here we have written we should replace this P by R by conditional S. हा जर फॉर्म्युला आपण रिप्लेस करायचं म्हटलं व्हेरिएबल P, तर त्यासाठी फॉर्म्युला काय डिसाइड केला? R by conditional S. Then we have to replace these both the P's by using same formula, that is R by conditional S. रिप्लेस केल्यानंतर आपल्याला फॉर्म्युला काय मिळणार आहे? R biconditional S, conditional J and R biconditional S. म्हणजे आपण काय केलं इथे हे दोन्ही पीस आपण ह्या सेम फॉर्म्युलाने रिप्लेस केली. Then only this A is called as substitution instance of B. तेच जर तुम्ही असं केलं एकच P घातला कुठला तर रिप्लेस केला. सपोज आपण फर्स्ट P रिप्लेस केला बाय युजिंग दिस फॉर्म्युला आणि सेकंड P तसाच ठेवला तर तुमचा फॉर्म्युला काय येणार आहे R बाय कंडिशनल S conditional J and P. But this is not a substitution instance. Why? Because we have not replaced this second key by using this formula. जेवढ्या वेळा ते व्हेरिएबल तुमच्या फॉर्म्युल्यामध्ये आले तेवढ्या वेळा ते सेम फॉर्म्युल्याने रिप्लेस करायचे तरच ते सबस्टिट्यूशन इन्स्टन्स होते. That's why this A is substitution instance, but this second one is not a substitution instance for given formula. Understood now? Okay.
Yes, ma'am.
Good. So again, here some examples are given. Substitution instances of P conditional negation Q are. So first one is given as R and negation is conditional negation of J or M. Now from this, can you tell me which formulas are substituted for variables P and Q? P साठी substitution काय use केली आहे?
R and negation, yes.
Okay, and for Q?
J or M.
Yes, J or M. Correct. Now, if you consider second one, here P is replaced by R and negation S, as well as Q is replaced by R and negation S. Now, again, if you consider third one, P is replaced by R and negation S, and Q is replaced by P. And for fourth one, P is replaced by Q and Q is replaced by P and negation P. So these are the some examples. Okay, so I think today we are going to stop here. Remaining points we will see in next lecture. But still, if you want any change in revision, you can suggest me. So we can conduct it accordingly. Is this speed fine? एवढा स्पीड ठीक आहे का रिव्हिजन साठी? ओके, गुड.
Yes, ma'am.
या. Present, roll number 1.
Yes, ma'am.
2. Roll number 2. 3.
Yes, ma'am.
Roll number 4.
Yes, ma'am.
5. 6. Roll number 6. 7.
Present.
8. 9.
Yes, ma'am.
10.
Present, ma'am.
11.
Yes, ma'am.
12.
Yes, ma'am.
13. 14.
Yes, ma'am.
15, 16,
Yes, ma'am.
17,
Yes, ma'am.
18,
Yes, ma'am.
19,
Present, ma'am.
20, 21,
Yes, ma'am.
22, present, okay. 23,
Yes, ma'am.
24, 25,
Yes, ma'am.
26,
Present, ma'am.
27,
Present, ma'am.
28, 29,
Yes, ma'am.
30,
Present, ma'am.
31,
Present, ma'am.
32,
Present, ma'am.
33, 34,
Present, ma'am.
35, 36,
Present, ma'am.
37,
Yes, ma'am.
38,
Present, ma'am.
39,
Yes, ma'am.
40,
Present, ma'am.
41,
Present, ma'am.
42, 43,
Present, ma'am.
44, 45, 46,
Yes, ma'am.
47, 48, 49,
Yes, ma'am.
50,
Present, ma'am.
51,
Present, ma'am.
52, 53, 54, present, okay. 55, 56, 57,
Yes, ma'am.
58, 59, 60, 61,
Yes, ma'am.
62, 63, 64, 65, 66, 67, okay, 66
Yes,
is
madam.
present. 67 is also present. 68,
Yes, ma'am.
69, 70, absent roll numbers, roll number 2, 5, 6, 8, 13, 15, 24, 28, 33, 35, 42, 44, 45, 47, 48, 52, 53, 55, 56, 58, 59, 60, 62, 63, 64, 65, and 69. Okay, so today we are going to stop here. Thank you.